Hello, dear friends. In this video, we are going to see about vector storage. Basically, we will be using vectors. Most probably, we are discussing in the context of RAG in other videos. So, based on that context, we are going to see about what is in the previous video we saw what is vector. So here we are going to see about vector storage. So please listen to the previous videos as well. So what is vector storage and why we want this vector storage means we know that what is a vector? It is a numerical representation for the text. So we want some place to store it so that we can able to because text is a huge data, no? So if you want to do any computation, if we if you want to compare something, so if we have a vector storage, then comparing our data, the query which we make with the millions of other vectors will be actually, if you want to do that, it is computationally expensive. So when we have a vector storage, then the search will be made faster and efficient. So this helps us to store the vectors, the numerical representation of the text, and also we can able to retrieve it in a faster manner. So the embedding can be easily retrieved. That's the purpose we want a vector storage. So computationally, comparing a query with the millions of vectors is so expensive. So when you have this kind of arrangement, then it will be easy to do that. So now let us see what is vector storage and a vector database. So storage in the sense it is like a system used to store embedding. So it's mainly focused on storing and retrieving the vector efficiently. But when you say about database, so this is specifically made to manage large collection of embeddings. So when you go in real time for any application, the embedding dimensions will be very large. So in that case, vector database is very useful and it is specifically made for that. And it provide efficient indexing and we will be discussing about this indexing soon. And then fast similarity search, better scalability. So for all these things, this vector database is more useful. So it is more advanced than the vector libraries also. We are going to discuss that terminology as well. So there are three important levels available first for this vector database storage. So here first one is indexing. So we know that if a book without index, what happens? But if a book with index, then it's searching is very easy, right? So the first step here is indexing. So it will organize the vector for fast retrieval. If you have an index for a page, if you want to search anything, we can quickly get it out because of the index. Same thing here. So to do this indexing, we have lot of algorithms. Most familiar ones are KD, trees, and Annoy. So this help to reduce the search time because of this indexing. And the next one is vector libraries. So whenever we want to do any mathematical operations like similarity checking or to find the distance calculation or dot product in those kinds, we can go for vector libraries. And then we have the vector database. So example of vector database is Milvius Pinecone. So this helps us to store and manage large volume of vectors and it uses this indexing techniques for better searching. So this components all together we use in RAG. We know already in the previous videos we have discussed about the working principles of RAG. So in that place only these vectors are coming. So where the in the RAG we use this vector concept. So when we have this kind of arrangement, it will help support RAG for the faster retrieval of the relevant information whenever we want to do any search or want to get some data from the external grounded resources. And what is this vector indexing? As I told you, if you in a book, if you have an index, then it is very easy for us to do the search. So this is similar to searching in a very faster way. So in vector indexing, it is a similar vectors are arranged in the way that makes easier for us to find do any kind of searching. So why searching is important? Because the main purpose here for this vector database itself is to find something. So we have stored something and we want to get it back. So comparing a query vector with millions of already stored vectors is normally very slow process. But when we include this kind of indexing, it reduces the search space and improves the speed so that we can get the result very easily. So this kind of vector indexing is specifically important for high dimension vectors. So like text embedding. So where we have a huge number of dimensions. So in that cases, if you have an indexing, it is very easy for us to search and the result will be obtained very soon. The speed is very high because of this indexing. So we want indexing. So some of the common indexing algorithms are, as we discussed already, K, D, tree. So it organizes the vectors in a form of binary tree structure. This algorithm is specifically good for low dimension data. Whenever the dimension is less, we can go for this algorithm to do indexing. So performance, as we increase the dimension, the performance will decrease because it's specifically for a low dimension data. Now, another algorithm for vector indexing is ball tree. This is specifically high dimension data. When we have a high dimension data, KD algorithm doesn't suit for that. So we can go for this ball tree. So here we are arranging the data into a nested hyperspace like this. So, but if you use this ball tree for low dimension data, then it will be a little bit slow. So KD should be for low dimension data and ball tree should be for a high dimension data. And some other algorithms are product quantization. So this algorithm, while indexing, divide the vector space into small subspaces. And the important task done here is it compresses the vectors to save the storage. Since it is compressing, sometimes accuracy may be last, but it is very fast. And the next one is locality sensitive hashing. So this is another indexing algorithm. So this is similar. This map is similar vectors like in the same pattern of hashing bucket, hash bucket. This is also good for high dimensional data, and sometimes it may do some incorrect matches like false positive and false negative is possible in this algorithm. And other algorithms are hierarchical, navigable small word. So HNSW algorithm. So this is graph-based algorithms, and it create a graph layered graph structure. So it's provide high accuracy, fast in search, and good for scalability as well. And in the modern vector database, it is so popular. And similarly, we have other kind of indexing algorithms also. Some of them are graph neural network, graph convolution network. So these are all using the graph structure for a better similarity search. The next one is vector library. So we know that already vector database is a place where we store a huge dimensions of text embedding. And because we store it when we do a comparison, it is very easy because it's properly arranged, it's efficient for searching. But this is for vector. Another way to do that is vector libraries. These tools are used to store and search vector embeddings also efficiently. Something used for similarity search. So it is already built inside the Python. So most probably it is using the approximate nearest neighbor algorithm to find the similar vectors quickly. So this support different indexing methods like tree-based search, clustering method, graph-based methods are used to do indexing in the vector library. So these libraries are mainly used for semantic search. We know that it's a meaningful search, recommendation system, image search, RAG system. We use vector libraries. So most popular vector libraries are FACE, that is Facebook AI Similarity Search. It is developed by Meta, that Facebook, designed for large-scale vector similarity search. It supports multiple indexing algorithms like product quantization, locality sensitive hashing, HNSW. We saw the algorithms previously. So this FACE will be supporting all kind of algorithms. This will also work fine with CPU and GPU and make it fast. And one of the most popular vector library is in GitHub is this one. And the next one is approximate nearest neighbor ANI algorithm is developed by Spotify, written in C++. It uses random projection trees, efficient and scalable for high dimension data as well. It's popular for the nearest neighbor search algorithm. So whenever you want to do in that kind of search, which means nearest neighbor, you can go for ANI. And other algorithms are HNSW, LIB. So this is based on HNSW algorithm we discussed previously. So it is fast, memory efficient, and it is also good for high dimension data. Another one is non-metric space library. So it is an open source similarity search algorithm. This also support all this algorithm. So it is specifically for complex vector spaces. Other one done by Microsoft is SPTAG. It is also a vector library developed by Microsoft, support ANN search, and also it uses the algorithms like KD, tree, balance, k-means tree, graph-based tree. So this graph shows the like star history for this open source vector library, how it is used and how it is popular. You can see by this. Sophia's is most popularly used. And this is a reference where I have taken this picture. And here are some of the vector database as well. So now you might have understood the difference between library and database we will be discussing. So basically the vector database is built to store and manage vector embedding. So you can store and also manage it in an efficient manner, in a faster manner whenever you want to do the similarity search. And some of the important features when compared to others, metadata, storage, filtering, scalability, data management, all these things can be easily done. So unlike the basic storage vectors, vector database provide a complete solution for handling the query vector database. So that's a specialty. So where we use this vector database is whenever you want to do a semantic searching, including document search, image search, recommendation system, audio, video search. In all these cases, you can go for vector library. So they can also store machine learning models and their embeddings as well. So other common use case where we use this is in anomaly detection. So like a fraud detection. So whenever you want to find an unusual pattern in the data, we can go for this kind of database. Whenever we want a personalized recommendation, and based on the user behavior, you can go for it. In NLP, we can go for it for sentiment analysis, text classification, semantic search. We can go for it. So why we can't use a traditional database? Why we want a separate vector database means traditional database is not optimized for high dimension space. Since when we use a text, the dimension is very huge. So for high dimension vectors, traditional database cannot manage it in efficient manner. So we want a specific vector database to handle thousands of dimensions, large scale dimension data. And it is also very fast. Whenever you want to find a similarity with a given query and already stored embeddings, we can quickly do it because it is customized and personalized, optimized for that. So what are the key characteristics for this vector databases? It is efficient, retrieval for similarity search, and designed specifically for similarity search, support high dimension data, enable advanced semantic search, scalable for long data sets. These are the speciality of this data database, which specifically for vectors. So these are some of the popular vector database, and this is how it will be stored. So most probably ChromaDB, Pinecone, VV8, all these things. So here we have a simple example for everything. We have for every words we are a phrase, we have a vector representation of it, and it is stored in the database. So vector database can store unstructured data as well. So text, image, audio, video. So all are converted in the form of vector embedding, and it is stored inside the vector database. Even it can be a text or an image or a video or audio. All this kind of multimodal modalities can be stored in the vector database in the form of embeddings. And so when the dimension is also huge, so this this database allows us to find a similar item quickly, also with the help of the nearest neighbor search as well is possible in the database. So here, if you want to find something similar to it, and when we convert all this thing in the form of vector data vector data, and we want to find a similarity, could do it in a quick manner. So each data point, whether it can be a word or an image or a document or anything, is transformed in the form of numerical vectors using some of the ML techniques. So already we saw in the previous video some of the sentence transformer model is also available to do this embedding work. So this numerical vectors only we call it as embedding, and the model is trained such a way that these vectors capture the essential features and the characteristics. So it's just not just a number, but this number has all the essential features of that particular text or an image or whatever it may be. And the characteristics also represent in the form of a number. It's not just a blind number. It has a lot of meaning in the numbers. Because of that, only we can able to find a similar patterns or similar other input, maybe a text or a video or anything. And this we already discussed the vector indexing. So without indexing, it's like searching a book without index. So with indexing, it is like searching a book with index. So it will be efficient, right? So the some of the common indexing method are flat index, HNSW. This is a fast searching way, and IVF clustering. These are some of the vector indexing. So next one is vector library. So that provide the vector indexing and the similarity search algorithm within it. So it is mainly used inside the Python application. So here is an example how you can import it from the LangChain, and using this Facebook AI similarity search, we can give the document and the embedding, and we can able to store it in an efficient way. If you want to find the similarity, also we can easily do it. Some of the vector libraries are Face and iScan. All these are some of the important things. Specifically, it is inside the Python application itself. So it will store vectors in the memory or local disk, perform similarity search, fast nearest neighbor search. So this is all possible with this vector library. So basically it is for providing vector index and similarity search algorithm. So this is basically for this. And the vector database for the storage and the management. So here we have an algorithm for indexing and the similarity search alone. But we can do this as well. And here we more particularly discuss concentrate on the storage and the manage vector. So here we have Face is for just a powerful tool. It's like a library, and database means Pinecone. It is like MySQL, MongoDB. It's like a full database, but Face is like a NumPy. So it's a Python application. So as I told, it's written your Python application. So here are some of the examples given here for database: Pinecone, VV8, Milvus, Quadrant, ChromaDB, and all these things. So the full database system designed specifically to store and manage a vector. So here is a simple definition difference between vector library and vector database. So vector library is basically for similarity search algorithm, but database is for a complete storage management and scalable infrastructure for vector database. So here is an table which shows the difference between vector library and the vector database. Type means vector library is like a tool, but database is like other database like MySQL, MongoDB. It's like a full database system. That is vector database. Then storage in vector library, it's a temporary storage only, but vector database is a persistent storage. Scalability is limited in vector library, but it's high in vector database. But metadata is not supported in vector library, but it's there in the vector database. API access is not there in the vector library. It's there in the vector database like REST and SDK. And deployment, it's only inside the code. But here, vector database, it can be based on server, and also through the cloud we can do it. And where we can use this vector library for the small demos, a small project, we can go for vector library. But for production level, you have to use vector database. So this are some of important information we should know about vector storage. So which we learn how it will be playing an important role in the RAG. Hope you have understand this concepts. Thank you. God bless you.